can't hide from us. We catch you in the hallways if you missed an assignment and what have you. So what I'm going to be talking about today, as soon as I pull up my PowerPoint, is I'm going to give you a quick overview of what physics is at ENH and what engineering science is. Now, I don't know who's interested in what. Maybe we'll just take a few seconds at the beginning. You can maybe tell me a word or two about who you are, what it is that you're interested in. That's going to help me kind of maybe answer some of your questions as I'm doing the PowerPoint. And certainly it's not going to be an hour long. You're going to have plenty of time to ask questions. And as Tracy just mentioned, if you want to ask a question in the middle, stop me, feel free to do that and ask questions. So how about, Chica, we start with you. You can tell me what you're interested in, where you're coming from.
Wait, for me?
Yes.
Okay. Well, I just want to know my name is Chica Miles Marie. I'm from Marlton, New Jersey. And one of my top majors is like you said, engineering. Mine's like mechanical engineering, computer engineering, a little bit of computer science. And I'm also an athlete. I do football. And there's other colleges are wanting me to join and visit these types of campus, which is great. So I'm just having more opportunities to I feel comfortable and feel nice. That's all.
All right. Sounds like you have some serious plans there. You're mixing a whole lot of very challenging academics, and football is not easy, but it has been done. It has been done. I can mention some of that at the end. Fantastic. Thank you. Keegan, how about you?
I'm from Richmond, and I would like to go into physics.
All right. Any particular branch of physics?
I would like to get a doctorate, but I'm not sure what in.
Okay. That works. Been there, done that. All right. So, doable. Any athletics?
I swim year-round.
Okay, excellent. You going to do that here?
That would be the plan.
Excellent. Yes. Very good. Thank you. How about you, Charles?
I just joined here to see. I'm a prospective transfer student, and I saw you guys were starting this engineering science major, and I kind of wanted to see what that was about, and then also maybe what you guys perceive as like the marketability of that degree, and then also just its application within the workforce. I guess that you guys have planned for that. So yeah.
All right. Excellent. Okay, so let me go ahead and pull up my PowerPoint. And then again, if you have any questions along the way, you go ahead and stop me and ask. All right. Let's see if I can actually do this. All right. Can everybody see this okay?
Yeah, I can see it.
Somebody needs to answer.
You're good.
Okay. All right, sorry. We just kind of somehow I got myself muted. I don't know how. All right, so physics and engineering. So here are my credentials, kind of, sort of. I'm a PhD in physics. But I also have experience working in an engineering firm. And so I come from this from different perspectives. I'm not purely academic because I did spend several years in an engineering firm. And before that, I was a pilot. And so I kind of have a mixed bag of things, which kind of makes it interesting because I can talk to students at different levels. All right, so let's see if I can, oops. Let's see how this is working. All right. Okay, so let's talk about physics first, and then we'll talk about engineering science. And so physics in general, I mean, this is one of the most fundamental of the natural sciences, meaning that we're just going to be looking for how things actually work. What is that about? You know, we're talking about nature and natural phenomena. What is that about? So you can look at nature from different perspectives. Biologists will do it from one perspective. Chemists will do it from a different perspective. And in physics, we're just kind of almost the most fundamental, in fact, of the natural sciences. And we're always looking for the why. So we're not happy with just describing. We're actually looking for the why. What are the laws of nature? Can we explain them? Can we write them down? So the language of physics, just like engineering, is going to be mathematics. And if we can write down an equation, that means we have some understanding of what it is that we're talking about. So physics is more about, you know, the study of matter, put down the motion and the behavior through to space and time. So understanding things from the very smallest of scales. So looking at what's going on inside the atom and inside the nucleus of the atom and inside the quarks, which make up the bits and pieces of the nucleus that make up the atom, and see how that works. How do they interact with each other? What is the importance of why do we have quarks and the importance of that? And of course, we relate that to, we have just overarching principles like the idea of energy, which is conservation of energy, which is a universal principle and how that applies. And of course, everything else related to that. So if you're a chemist, you're looking at things at an atomic or molecular level. If you're a biologist, you're looking at molecular on up. Well, if you're a physicist, you can look at stuff all the way down to the very smallest scale, all the way up to the largest scale, which is that of the universe. And so physics is very broad ranging. And again, we're looking at the same thing that the biologist or the chemist might be looking at, but we're looking at it from a different perspective. All right, so what are some of the skills that you would pick up as a physics student? Especially here, just because I know what kind of classes you're going to be taking. So certainly the primary skill of any scientist is going to be critical thinking, is being able to use logic and use the tools that you're going to be acquiring, things like lots of mathematics, lots of studying of the different branches of physics or chemistry and biology, and applying that to solving problems. And the problem solving skills that you do acquire in physics is probably the number one transferable skills, meaning that if you graduate with an undergraduate degree in physics, prospective employers will know that because you're coming in with a degree in physics in your pocket, you do have well-developed problem-solving skills, and it can throw stuff at you, and you can figure out how to solve those problems. It does not even have to be a physics problem. It could be any problem, because problems are problems, right? What do? You're faced with something very complicated. You don't try to solve it in one go, unless you can, but most real-life problems are not going to be that way. So what do? You take that problem, you break it up into smaller pieces that you can then solve, and then put the solutions together, and then you solve the problem. And so this is that's why I put it at the top of this list here. This is really important. It's going to be important for physicists. It's going to be important for any scientist, and certainly any engineer as well. What else do you pick up besides, and here I'm not talking about all the physics that you're going to learn, right? So these are the skills that are underlying all of the physics that you're learning. Certainly teamwork, you're going to get to do a whole lot of that. We're going to be, right from the introductory sequence, we get you to work with other people, because science is not done in a vacuum. You always work with other people. Engineering is not done in a vacuum. You always work with teams of people, so you need to learn from the get-go how to do that. And it's not something that you can go sit in a classroom and learn about. It's something that you have to do. So we just go ahead and do that. Technical skills, well, different types of things that you're going to learn in a lab are one type of technical skills. Also, you're going to do some computing, another type of technical skill. And there's a whole list of things that you're going to be doing. You might be working on research projects, so you might be learning how to solder. Well, that's not a physics skill, but it's still a technical skill, because if you're going to be doing electronics, that goes right into there. So there are a lot of things that you're going to be picking up as you're moving along. And certainly analysis and quantitative thinking, taking the math and applying the math to actual problems, being able to analyze. So look at complicated problem statements or tackle a research project. That means being able to figure out, all right, how am I going to look at this? What's going to be my approach? What's my goal? How am I going to do it? And those are all folded into this analysis and quantitative thinking. And those, again, are all of these are really sought after by employers. That's the kind of stuff that, again, physics or not, you don't have to be working in a STEM field to be using your physics skill, because these transfer to just about any job out there. So if you're going to be, for example, well, actually, no, never mind. I was going to give you an example, but that's not a good idea. So on the right-hand side of my slide here, I have some of the skills that you'll be using in STEM field, but again, that applies to a lot of other fields as well. And that is, again, why employers are looking for people specifically with this kind of STEM background to bring those skills that are really hard to learn if you're coming from other fields. If you don't have those already, these are really hard to learn, because it takes you 3 to 4 years to just kind of master some of these. So it's not something that you can just go to a workshop for 1 week and pick up. And so you can see a whole bunch of different things, manage people and budgets. Well, you don't do a whole lot of that here at the undergraduate level, but you might certainly get a little bit of it as you're moving along. If you're going to be doing a research project, for example, you might have a budget to work with, small one, but still one. And you can see solve technical problems, programming, use specialized equipment. Well, okay, so in labs, you will get to play with all kinds of different equipment, whether it is chemistry or physics or even biology, depending on which classes you're going to be taking. And so you get to learn how to use some of the more advanced stuff. We do have things like LabVIEW, which is something that you will encounter in either chemistry or physics. And LabVIEW is an industry standard for a lot of engineering firms, R&D firms. So there you go. You would pick up a lot of those. And of course, you get plenty of math, do a lot of modeling. That's the basis. That's the bread and butter of a scientific field. All right, so what else? What happens once you get all of these skills in your back pocket and now you're graduating? What are you going to do? Well, the neat part about physics, or the quirky part about physics, is that you can't just pick up, go online and go to one of the search engine and put down physicist, but only have an undergraduate degree, meaning that physicist is not necessarily a job like, say, a biologist would be a job that you would actually see. Physicist, not so much. Unless you have an advanced degree, you're not going to be called a physicist. But physicists are just all over at the undergraduate level. They go into all kinds of different jobs. So most physicists at the undergraduate level are what we call hidden physicists. They're going into all kinds of different jobs, and not necessarily those that are going to be related to physics. Some of them will be using their physics skills. Others are going to be using all of the soft skills and the hard skills that I just mentioned before. So if you see the breakdown here on the right-hand side of the graduates, you look at about 50% will go into the workforce, whether it is in the private sector or in academia or in industry or in the military, all kinds of things. There are all kinds of different fields. I'm going to talk about that on the next slide. A good section of our students go on to grad school. And so here you have either physics or astronomy or any variation on those graduate fields. It could be more than just physics or astronomy. It could actually be material sciences. It can be applied physics, all kinds of subfields to these broad classifications. And then you have other graduate schools, other fields, engineering. A lot of students start with an undergraduate degree in physics, and then they move on to graduate school in engineering. Certainly on the academic side, you can think about teachers. And so that's kind of not really, that's something that's always there. So you can certainly be a middle school or high school teacher with an undergraduate degree in physics. And so you can see the breakdown here. That's a rough breakdown, but it tells you that there are a lot of different options. And that's one thing about an undergraduate degree in physics. It gives you a lot of options. So when you go into the workforce, you can look in all kinds of different directions, and you're not just one narrow field for you to get into. There are a lot of different options. So let's take a look at some of the job titles that you might be qualified for. And here, those are broad strokes, right? It just depends on which classes you're taking. It depends on what kind of job that you're looking at. But a lot of jobs in engineering, and I'll come back to that in just a second. Certainly jobs in programming associated with any kind of programming. You're going to get some experience at the undergraduate level, and then you go on from there depending on what you want to do. So you do a lot of entry-level jobs that you can have access to, because even though you don't necessarily have an undergraduate degree in computer science, you will get enough of the critical thinking and analysis skills that you can slide into a lot of entry-level jobs with those and go from there. Business and finance, if you have interest in business, we have one of our current students who's a baseball player, is also doing a physics degree and a business degree. So he's doing all of these things at the same time. And so he's going to be going more into the finance business side of things. But he's bringing all of his critical thinking skills. And so that's going to make him a very, how do I say this, more detailed oriented and better able to handle some of the complex situations because of his background. There are certainly openings in the technical field, right? So you can just kind of go and work into labs all over the place as a research technician, as a research associate, assistant. So those are just basically kind of a breakdown of different levels of responsibilities. And that depends on the classes that you've taken and the job that you're going into. So any job where you would be assisting other scientists, whether they're physicist or chemist or biologist, you actually have a leg up when you're coming in with an undergraduate degree in physics. And of course, I've already mentioned teachers. And so if you have a physics degree, you can either get your certification, or you can actually, there are several places, because physics teachers at the high school level, science and physics, are in such high demand. Locally or regionally, that's a fact. That's a critical need, in fact. And so if you graduate with your physics degree, they will put you to work right away. And then you will be given a time period where you can go back and then get your teaching credentials. And that, of course, varies from state to state. But it's one of those things like, hey, I want to teach high school. I have a physics degree. I don't have my teaching certification just yet, but you can actually be working at the same time that you're getting a certification. So these are all options. All right. So I wanted to come back to engineering, because as you can see, there are a lot of different options here. And this is just, again, a sampling of some of the things that are available with a physics degree. But a lot of our students come in interested in engineering and is thinking, hey, I'm going to do physics as an undergrad and go on to some engineering field. And so this is kind of basically a segue of where engineering science comes in, because we have been sending students to engineering school, either through chemistry or physics, for many, many decades, in fact. But now finally, we have decided to put that together into a program and just kind of give you a leg up, so that if you're going to go into the field of engineering, we have something that's even more specialized, that more centered or more focused on the engineering skills, as a kind of a different option, if you will. So let's go ahead and go, or actually, let me stop. Any questions at this point? I take that as a no. All right. So moving right along then, let's talk about engineering science. All right. So the fact that it's called engineering science, as opposed to civil engineering or mechanical engineering or computer science engineering or whatever, it's because we don't have an engineering school. Our college is just way, way too small to have an engineering school. But what we have is we have a lot of faculty that actually have engineering experience or even backgrounds in engineering. Like in my case, I actually worked in an engineering firm for 7 years. So that counts for something, right? Not only that I have a graduate degree in physics, so there's a lot together, but we have faculty in chemistry, faculty in biology that all have had contacts with some field of engineering or another from different perspectives. And so we decided to go ahead and bring the people from physics, engineering, chemistry, physics, chemistry, and biology, and bring in, of course, all the math, so give you courses in math, and then put this degree together that's going to be preparation for entry into either graduate school in engineering, or it's going to be preparation for entry in the workforce at an entry level, depending on the type of job that you are looking for, type of industry that you're looking for, entry-level jobs in engineering. So I'll say a little bit more about that in a few slides. All right, so engineering science is just basically the science part is really important, meaning that you're going to get a really, really strong foundation in the basic sciences. So you're going to have a lot of physics, a lot of chemistry, a lot of math, and depending on your choice of electives, you can even do some biology to get you prepared, because we have a couple of electives in genetic engineering, and so you'd have to do some biology to prepare to take those. We have a faculty that have experience in nanotechnology, and so that could be one of the electives that you could take, so you would get that. We have a chemistry professor who has a PhD in material sciences, and so material sciences engineering, in fact. And so material sciences are some of the electives that you're going to have access to. And so all of these things are going to be put together into a very comprehensive and very sound and very strong degree that has a very strong scientific foundation. So that's the science part of it. Not only that, and when I say it's broad discipline here, meaning that you're not going to have 2 years of mechanical engineering. We don't have that. You don't have 2 years of electrical engineering, but you will get a lot of the courses that are foundational courses for those types of classes. And there are actually a lot of overlap. We have a class in electronics, for example. Well, electronics is certainly one of the classes that you would have to take if you're going to be doing electrical engineering or computer science engineering. We have material sciences. Well, those are some of the courses that you would see in mechanical engineering or surface engineering. And there are all kinds of different branches of engineering. Can't keep up. And so a lot of these classes are going to be, you're going to see those if you're going to be looking at curricula from different engineering schools. You'll see a lot of overlap. Thermodynamics, mechanics, right? Those are just bread and butter type of foundational courses that you see in those different disciplines. So you're going to be doing a lot of that. You're going to have a strong foundation in scientific principles, but not only that, what we're going to do is this degree actually integrates not just the chemistry, the biology, the math, and the physics, but we also throw in, because you are in a liberal arts institution, we're going to put in, you're going to take some classes in the arts and humanities and social sciences, some of the required classes in the engineering science program are going to be, in fact, ethics, to help you just kind of know about how to handle ethically complex situation. Engineering is not done in a bubble. Engineering solutions have impact on people, on the environment, on society as a whole. You need to be able to handle those. So we're asking you to actually do an ethics class to get you started thinking about these issues, and maybe have a few tricks in your bag to handle those. We also are going to ask you to take a class in science communication, because again, engineering is not done in a bubble. You will need to be talking to people. You will be talking to people in your company or your department if you're working in the government, for example, or in a lab. So you need to be talking to other people, plus engineering is done with clients on the other side. And so you're going to need to be talking to clients as well. And so you can be in a really good position. You need to be in a good position to be talking to different people, different types of people from different backgrounds, and be able to understand all of them precisely. And so scientific communication just fits right in. So that's why we're asking you to take that kind of a class. And also we're going to take advantage of the fact that we have people that are well-versed in engineering, environmental science to kind of, and sociology and other disciplines, economics, for example, and that can then just put engineering through a different lens, or look at engineering problems or engineering issues through different lenses. And that just kind of helps you become a really open-minded and well-rounded individual. So you can get into any company and be able to talk about different issues and understand those and be aware of them. Again, you're not, even if you're working eventually as an engineer, you will not be working in a bubble. I keep saying that word, I need a different word here. And so you need to be able to talk to people, and you need to be able to be aware of the impact of whatever field you're working in on the world around you, and be able to just not sweep it under the rug and forget about it. All right, so I got off my soapbox here. And so what are the skills that you're gonna get out of an engineering science degree? Well, you're gonna get a lot of science, strong foundations. And no matter what field of engineering you go into, people will be able to throw stuff at you, and they will know that you know how to think. You have the critical thinking skills, you have background in chemistry and physics, maybe even biology, you've seen some of the ethics, you've seen some of the economics, you've seen some of the environmental issues, and so on and so forth. You will be coming in with a very well-rounded and versatile degree. And so that whatever engineering firm or job you're going to land into, you can adapt. You will know how to get the knowledge that you need and then take that job in the direction that you wanted to. But more importantly, if you have an education that is so multidisciplinary, you are more likely to be able to come up with some innovative solutions to engineering problems. Because that's one thing about a civil engineer, for example, that's only seen book stuff. By the time they come out of their degree, they don't necessarily know about the environmental issues surrounding all the civil engineering projects, or same thing for mechanical engineers or electrical engineers. So that's one thing that we're going to try to promote as we're putting this degree forward, and we're hoping that our graduates are going to have enough knowledge so that they can think outside the box and start thinking in terms of what we call green jobs, right? Environmental friendly jobs. These kinds of jobs are just asking you to not just build a concrete barrier somewhere to fix this problem of erosion, but think about what the impacts of that concrete barrier is going to be. Are there other solutions? Are there more environmentally friendly solutions out there? And what about if you're building something where it's actually bulldozing somebody's rainforest? That's not right. Well, what else can we do, right? So that's where the innovation comes in. And these are the stereotypical problems, but there are just so many different examples of problems that we're faced with in today's society that require people to think outside the box. And sometimes the less book learning, the less time you spend with your nose in a book or in a specific book, which makes you really, really good at what you do, but not necessarily so good that you can actually think outside that book. And that's what engineering science does. It gives you that foundation so you can not necessarily know all of the ins and details of a specific branch of engineering, but know enough of the techniques and the thinking skills that you can come up with new stuff. And that's where tomorrow's engineers are all about, finding new stuff. The old stuff doesn't work anymore. A lot of the old stuff doesn't work anymore. And a lot of the old stuff is failing now, right? The entire infrastructure of our country is failing. Well, we need to not just replace it with what was there before, but just think about new stuff, new options, and new technologies. So there you go. All right, so what can you do after graduation? Well, a lot of our students are going to go on to grad school. If you want to be a civil engineer, then you need to go on and so basically you have two paths. After graduation, you can either go to graduate school or you can get a job, get more training on the job before you decide what you're going to do, right? Like, do I go back to grad school or do I stay with the job and get on the job training and this is good for me? So evaluate, is that the right field for you? What do I need to do to get where I want to be? But if you're set that you want to be a civil engineer and then you want to start your engineering career here because of a sport or any other, you want to be on a great campus with a really good group of people, then graduate school will then be the solution for you, because then once you graduate, you go on to grad school, get a master's in whatever engineering field that you want, and then go on to resume the normal path of becoming a licensed engineer. Other avenues. So in terms of jobs, again, you have a lot of different options, just like you would in physics, because of your formation. So you could do things like technical writing and communication. So there are all kinds of different jobs in different companies that require the engineering knowledge, but not necessarily that are number crunching engineering type jobs. You can still do those, but you can also do other things within the company. So examples are technical writing and communication. They always need people that know what those technical terms are about and being able to articulate. Well, that's where the science communication course comes in really handy. So, and the lab reports and all that good stuff. Analysts in all kinds of different jobs. They need people to analyze, to just kind of take data, manipulate it, understand it, present it. So all of these are just kind of all grouped together. A lot of people in marketing, PR, client services, and I kind of put that in there in the idea that engineers need to be able to talk to clients. And sometimes engineers are not so good at talking to their clients because they get to be so technical. But you, as somebody that comes in with a broader education, that can still understand all of the technical aspects of what the engineer is talking about, but then be able to relate to the people on the other side of those engineering problems. So there are a lot of jobs that way, that are along those lines. So that's kind of all in that category right here. And you might be interested in starting your very own company. And so that's another job right there. You can make your own job because you have the knowledge, you have an idea of what's happening and what you want to do, especially if you're thinking outside the box and thinking about new technologies or different technologies. It might be something that you decide, hey, I don't need to be giving this to somebody else. I can do my own. A lot of course, new companies are starting exactly that way. You get that idea as an undergrad, then you're going to go ahead and push it forward on your own. So the type of environments where you can be picking up any of those jobs, certainly a lot of government jobs out there. Think about the Department of Transportation, Department of Energy, all kinds of environmental related jobs at the government level. And so you have a whole structure of jobs where coming in with engineering skills would be very useful. A lot of private engineering firms, so consulting engineering firms, that's where I got my 7 years of engineering experience. I was working in a small engineering firm, a consulting firm in electrical and mechanical engineering. And so just smaller projects, oftentimes more specialized, or you have big consulting or big engineering companies as well. And then major industries. So for example, here we have Eastman here in Kingsport. Eastman hires a lot of engineers and also has a lot of different jobs that are engineering related. And they are dying for graduates from local institutions because they want people to actually stick around here. And if you're not familiar with the environment of Southwest Virginia, you might not want to stay here. And so Eastman is one of those big industry that you can start in Kingsport and then you can migrate on to all of their different locations in the United States. And so just many, many jobs open there and different avenues as well. And the list goes on. I could have put, dot, dot, dot here and added more. All right, so that's kind of my overview of physics and engineering at Emory and Henry. Hopefully I did not bore you too much. For more information, of course, you can go onto the college website, either under physics or engineering science, get a little bit more information about the different degrees in terms of looking at what classes are involved. And then, of course, you can always send me an email. Just kind of shoot me an email and say, hey, I got this question, and I will do my best to answer you. So let me go ahead and stop sharing here for a second and go on to, if you go to the website, you go in, for example, under engineering science, you will see some tabs here to give you some information about the degree. And if you look at under degrees and requirements, you will see a list of all the courses that are required for the engineering science degree. And so the core courses, as you can see, Intro to Engineering Science, of course, Material Science, Electronics, Thermodynamics. You would be doing a capstone project, so you will take all of those skills, putting them into a project at the end. So very applied here. So it's kind of neat. Some engineering electives. So I mentioned before, material science, genetic engineering, robotics, nanotechnology, instrumental analysis, all related. So there you have to kind of think about, how am I going to sequence my courses to get there. Foundation course, as you can see here, this is not a physics degree, right? You have a lot of chemistry, a lot of math, and a lot of physics. And we're putting all that together as all those foundational courses that are going to let you be able to function in the, oh, am I not sharing my screen? Yeah, I'm not sharing my screen. I'm so sorry. Yeah. Okay, let me try this again. Sorry. So I was talking about this. If you go to the engineering science website on the college website and you go under degrees and requirements, you have a list of all of the courses that that are required for the degree. And so listing all the required courses, including capstone project that I just mentioned, and then some electives. Then you have the foundational courses of physics, chemistry, and calculus, or math, I should say. And you can always throw in more math in there. And then, of course, the other requirements, I mentioned science communication, so that's one of the requirements, ethics, a computer science or programming course. And then right now we have a short list of electives we're working on getting more of them. So environmental related courses and also economics. So depending on your choices and where you see yourself going in terms of your career, you would then pick up some of these electives. All right, so let me go ahead and stop sharing for real right now. And let me stop and ask for any questions or anything that I can help you with in terms of those degrees.
I don't have any questions, but it was a nice presentation.
Well, thank you. Hopefully I didn't confuse you too much.
Nah, I wasn't really that bored.
Okay.
I'm all good. I've had all my questions answered, so thank you.
You are very welcome. Also, if you have any questions for admissions, Tracy is right there standing by if you have anything else that you would like to ask from that side of things.
Thank you so much, Dr. Merle. One of the things that I do, I would just do super quick. One of the things that I do like to always tell my students, because I do get students asking me when we originally had pre-engineering, I am a past start engineering student, but didn't quite make it through the program. I went to a very large engineering school with 300 people in my chemistry and physics classes, and I got lost. So one of the good things that I can definitely say for Emory and Henry is our small class sizes, and you're not going to get lost If you feel like you are getting behind, then we have the faculty that can actually take the time and teach you the courses if you are just struggling in some of those tougher classes. So that's one of the things I always like to tell my students who are looking at engineering, because I have that past experience of going through a very large school into their engineering program and not making it due to just the size of the classes, and you do not get that personalization like you do here.
Not only that, the large engineering schools are going to be competitive programs. They bring in 200-300 students knowing that at the end of the first semester, half of those students are going to be gone at the end of the first year, and a third of those students are going to be gone because they don't have that much room in the upper level classes.
Yeah.
So we're not in a competitive environment. We're here to get you to help you get and be the best that you can. And so you can't hide here. That's certainly one thing. Because of small classes and small departments, you cannot hide. You don't turn in your homework, I will come and get you. I will contact you. I will stop you in the corridor. I will make sure that you're making good progress and that you're not falling in the cracks and just being kind of forgotten as just a number out there. That's true of the entire college. For every professor, every class that you're going to have, it's always the same. So you have access to us because we're always kind of living in our offices, if not via email, but certainly also we are always looking out for you guys.
All right, so if nobody else has any questions, we will go ahead and wrap this up. Thank you so much, Dr. Morrell, and thank you everybody for participating. I hope you got a lot of information out of this, and this was being recorded, so you'll probably see this passed around because we will use this as really good material to continue to grow our engineering science program.
So thank you very much, everybody. And again, if you have any questions, anything that I can help you with, do not hesitate.
All right, thank you.
All right. Clyde, did you have any questions?